Thanks, I think.
Sorry. What?
Do you need a pen? Do you need me to get this one? You're welcome. I'm just glad it didn't hit me. Okay, so just as a quick rehash of what we discussed yesterday, we talked about how if you have a parabola, right, that you've got landmarks. So you've got like your vertex. Now, this I did not tell you, and this is important information. In algebra, we use H and K to represent the X and the Y value of your vertex. Okay? H and K. You have this axis of symmetry. Remember that guy? Which is just a horizontal line. Right? And the equation of that is going to be x equals whatever h is. H being the x value of your vertex. Right? And then you've got your x-intercepts. And your x-intercepts are also known as roots. They're also known as solutions. They're also known as zeros. And you have your y-intercept. And it's just called a y-intercept. So those are all landmarks that you can utilize when you're trying to graph a quadratic equation. Okay, so today we're going to talk about how you find those things. So we're going to start off. Let's look at number 1 on that practice side of that paper. And I'm actually just going to write it on my paper here instead of on there because it's just crowded on that page. So quick reminder. This f of x, remember that is function notation. And that stands for function of x, or that's how we say it. We say function of x, or we say f of x, and it just means y. We're just replacing y with that, right? So that's a y. That's all that is. Okay, if you look at that equation right there. So you're looking at that equation. Is there a way to look at that equation and identify the y-intercept? Why? So, if we put 0 in here and we put 0 in here, saying x is 0, that's on the y-axis, x is always 0, right? What do we have left? 15. This guy right here, that is your y-intercept, right? So we've already identified one landmark for this, and that's our y-intercept. So our y-intercept for this is equal to 15. Okay, so that's where that sweet baby is crossing the y-axis. All right. So far, so good. Are y'all hot, or is it just me? Okay. Okay, now we need to be able to find these other pieces. And so to do that, and this is where your note taking comes in, okay? You're going to want to write this stuff down. So first of all, you know this is what's known as standard form of a quadratic. So this is standard form. And this is what you see frequently. That's what you see a lot of, where A is a number, B is a number, C is a number. Now we just identified what is C. In the problem that we're using, it's 15, but what do we call it? That's your y-intercept, right? So your C is your y-intercept. The A is what tells you if it opens up or opens down. The A tells you how wide it is, how narrow it is. We're going to get more into that on a later date, okay? We also have another form. This form right here is called vertex form. Okay, now the vertex is the H and the K. This is your X value. This is your Y value of your vertex. I want to point out to you that says minus H, right? So if your equation says X minus 2, what would the value of H be? Okay, let me write it because I know some of y'all are super visual, right? So if it said X minus 2, but the formula looks like this, it's a positive 2. So H would be a positive 2, right? If it said X plus 2, but remember the formula looks like this, then your H is actually a negative 2, right? Now your K is the same because it's plus K. So if K is 3, it's 3. If K is 5, it's 5. If K is 7, it's 7. Why is this not kicking on? Like any other time, that air conditioner would be running nonstop in the afternoon. And today I am hot and about to melt, and it will not kick on. Okay, so standard form, vertex form, right? Now, this next part that I'm about to show you, you do not have to write down. As a matter of fact, I would suggest not writing this next little piece down, okay? I would suggest just watching and seeing what's happening with the math, all right? So, if I take this right here, and I need y'all to really focus, so I'm going to minimize what you see. Is there anybody else who is not sick but is having so much congestion in their head? I am not sick. Like, there's nothing wrong with me, but my head is so congested. Me too. But I don't feel bad. Like, there's not just this. And like, I sound weird. Like, I can tell I sound weird.
It was like 70 2 days ago.
Yeah.
And now it's like 40 again. So.
Okay, so this is what we've got, right? Now, I'm going to expand this out. I'm going to expand this out. So I'm going to take this X minus H and I'm going to square it, which means I'm doing X minus H times X minus H. Okay. Now, you guys know how to multiply that, so we're going to do X times X, X squared. X times negative H, and you can either write it as negative XH or negative HX. It would go either way, right? So I'm going to do it with the H first because X is my variable and H represents a number. Okay? And then I'm going to do negative H times X. So once again, I get negative HX again. And then I'm going to do negative H times negative H, which is positive H squared. Are y'all with me so far? Okay. We just squared it. That's all we did. We did this at squared. So we multiplied that times itself. We actually squared it. And I did it out the long way instead of doing the short way. Okay? Now, I have some like terms, right? So I can do X squared minus 2HX. Right? All I did right there was combine these like terms. That's it. That's all I did. Combine those like terms. And now I'm going to do this distributive property and multiply this out. So I'm going to have a times x squared negative 2a times h times x plus a times h squared, and then that plus k at the end. Y'all with me? Okay, so all I did was take this original equation and just multiply it all out to get rid of those parentheses, and then combining like terms, blah, blah, blah. Okay? Now, let me show you why I did this and why I told you don't have to worry about writing this down, okay? Because we're going to use that and compare it to this. Now, this is standard form, right? This is A would be a number, B would be a number, C would be a number, right? Do y'all notice that we have ax squared and ax squared? Do you notice that this term is the only term that has just an x in it? And then this term doesn't have any x's at all? The a and the a are the same in both equations. Ax squared is the same thing, right? This bx is equal to negative 2 times a times h times x. Negative 2 times a times h times x is equal to bx. Now, since they both have x, what would happen if we divided both sides by x? What? It'd cancel on both sides. So, really, it doesn't matter what x is. This is what we've got, right? Because regardless to what x is, we would still just have this. Y'all with me so far? And then ah squared plus k is equivalent to c. So far, so good? Now, the point behind why we're doing this is because we want to know if we've got an equation in standard form, that equation that we have in standard form, where we know A and we know B, could we find H? So if I have this equation right here, can I solve that for H? Can I get that H all by itself? What would I do to get rid of this? We're going to divide by it, right? So if we do it to one side, we got to do it to the other. That means that H, now remember, H is the x value of my vertex, what H stands for. The x value of my vertex. So H is equal to B divided by negative 2 times A. And that is how we find the value for the x value of our vertex. Does it make sense? And then if we wanted to find the y value of our vertex, that's called k. How would we get rid of ah squared over here? Subtract ah squared. So k is equal to c minus ah squared. Notice we have to have h for this. Like we have to find the h first and then use it to find the k. Y'all see what I'm saying? Okay, these two, this and this, you need to make sure you have written down. H is equal to b over negative 2a, and k is equal to c minus ah squared. And I'll rewrite them if you need me to. Huh? Well, what we just did right there, Jared, it's not something you have to do every time. That's just something that was me teaching. So here's the thing. I could have just given you those two equations. And for most of you, it's not going to make any difference if I just give them to you or if I go through the process. But there are a handful of people in every class that seeing that and seeing where those come from will help them to understand what they're doing. You see what I'm saying? So that's why I went through the process of this is where they came from. So that it's not just we're just memorizing crap just for the sake of memorizing it and we just made this up. Like it didn't come out of thin air, like it came from a place. That's where those equations come from, a place. Okay? Now, once we have those, once we know those equations, we just utilize them in a problem. Okay? So if we go back to that problem we were working on, now that we know these equations. Okay, so we go back to this problem right here. And we know that h is equal to b divided by negative 2 times a, right? And what is b in this problem? Remember, this is ax squared plus bx plus c. So what is b? Negative 8. And then what is a in this problem? 1, right? So what is, this is going to give us negative 8 divided by negative 2, which is 4. So our h, which is the x value of our vertex, is 4. That's also our axis of symmetry. Right? So here's what we know. We go to our graph. We know that right here, our vertex is going to be somewhere on that line. Somewhere. We don't know where, but somewhere on that line. We know that this is going to be our parabola going this way. We know that our y-intercept was 15. Esteban, that was not nice. It was really funny, but it was not nice. Okay. This graph, 15 won't fit on. We have to count by twos. So we're going to count up by 2. 2, 4, 6, 8, 10, 12, 14. There's our y-intercept. Well, we can do two different scales. We can count by twos one way and ones the other way. That's what we're going to do. We're going to count by twos on our y-axis and ones on our x-axis. Okay? So, now, we also know that since this is our axis of symmetry, we have that point over here. We have a matching point right there. Because whatever's on this side's got to be on that side. Same thing. Right? Okay, next part. We need to find our y value of our vertex. So we're going to go back to our paper, and remember our y value of our vertex is our k. And to find our k, we have to do c minus ah squared. C being, in our equation, what is our c value? 15, right? What is our a value in this equation? 1, right? What did we find for h? 4, right? And then we're squaring that. So when we do this math, what do we square first? 4, so it's going to be 15 minus 1 times 16. So it's going to be 15 minus 16, which is negative 1. This is our k value. Now remember, our k value is the y value of our vertex. So we now know that our vertex is 4, negative 1. So we can go back to our graph and we can do 4, -1. And there's our vertex right there. Now, really, we need to find one more point, right? So we could pick any number between these numbers here, put it in for x, and find that value. So it doesn't matter. Pick any number. 2. So if we put 2 in there, we've got 2 squared minus 8 times 2 plus 15, right? So 2 squared is 4 minus 16 plus 15. Y'all know what negative 16 plus 15 is going to yield, right? So what does that give us for that? 3. So if x is 2, y is 3, that's that point right there. And we know that we have a matching point on this side. Just like that. Now we can sketch this little graph out. And it looks just like that. And that's not guessing or anything. Like, we know exactly where it went. Y'all see how that works? Okay, so that was very long and drawn out for one problem because I was showing you where we got this stuff from, okay? But now that we know how to find it, where it comes from, now the finding of it will be really fast. So here's what we're going to start with. Start with identifying our A, our B, and our C. So what is our A in this problem? -1. What is our B? What is our C? Now, we know that C is equal to our y-intercept, right? So our y-intercept for this is going to be 12. We know if we want to find our x value for our vertex, we need to do h equals b divided by -2a. Now, what is b? -4. What is a? -1. So that's going to be -4 divided by 2. Is that correct? -4 divided by 2, which is -2. So our h value is -2. That means if we go over this graph to -2, that's where our axis of symmetry will be. And our vertex is going to be on that line somewhere. Okay? On that line somewhere. Now where? Well, we just got to figure out by finding our k. And to find our k, we will do That's right. So c minus a squared, right? In this case, our c is 12. Our a is -1. Our h was -2. And then we're squaring that. Now, what happens when you square a negative value? What do you get? Positive. So -2 squared is 4. What's 4 times -1? -4. But we've got 12 minus -4. What is 12 minus -4? 16. So our k value is 16. That means that on this axis of symmetry, we got to go to 16. Now, can we go to 16? Yeah, so we're going to count by twos again, right? So 2, 4, 6, 8, 10, 12, 14, 16. That's our vertex. Where was our y-intercept? What was our y-intercept? So 2, 4, 6, 8, 10. That's our y-intercept right there. So remember, we have to have a matching one on the other side. So over here, we've got a little matchy-matchy. Right? We need one more point. And it doesn't matter where we go. We could go between these. We could go outside of them. It's whatever y'all want to do. Pick it from the x-axis. Plug it in. I would probably do 1. If it was me, I would pick the number 1. Yep, so we plug it in here to our original equation. So negative 1 squared minus 4 times 1 plus 12. So 1 squared is going to be 1, but then that makes it a negative. So negative 1. Negative 4 times 1 is going to be negative 4, right? Plus 12. That's going to be negative 1, and negative 4 is negative 5. What's negative 5 plus 12? 7. So at 1, we should be at 7. So it's going to be 2, 4, 6, 7. And then we got to have a matchy-matchy over here, right? And you can see that graph. Now, what's unique about this one? What's different about him? Why is he upside down? What's your best guess? A is negative. A being negative makes him upside down. Okay, y'all try 3. Let's see if y'all can do it. Let's see if you can do 3 all by yourself. It's not a, if it's sideways, it's not a function anymore. It's just a relation, not function. Okay, I'm going to stop this.